Welcome, everyone. I'm Mary Johnson. I'm the manager of the 401 Tech Bridge. This is our very first Tech Talk, and we're excited to have Dr. Kunal Makodiya with us. We have been excited, as in my former role or one of my co-roles of managing the Rhode Island Textile Innovation Network, to work with Kunal and to learn more about his work with the Wearable Biosensing Lab, where he is the director. But he's an associate professor at the University of Rhode Island and has done not only research and teaching on campus, but also is working on several industry projects that he will talk in at least high level, a little bit of detail here today. So he has a presentation to share with you, and I'm going to turn it over to you. Thank you so much for joining us, and we look forward to your presentation.
Mary, thank you so much for having me here. 401 Tech Bridge, thank you for having me on the first Tech Talk. So I'm pretty excited about that. So what I will do is that I'll start with slides. Now I won't go into detail because Mary already told about what I do, at URI. So I'll jump right away with a little bit introduction of my lab. We call it a wearable biosensing lab. You will get to know what it means essentially when I'm going to show the projects. But essentially, our mission is to kind of building a diverse, talented leaders, of the future, particularly in the areas of the smart wearables, and and really it is our dream to serve the global citizens with our health technology. So our major focus is in health technologies, and one of the core areas that we work on is smart textiles. So we'll be kind of majorly diving deeper into that today in the talk. Here are some areas that we focus on. Here are some projects that we have been working on. So I'm kind of just providing you some highlights over here. But of course, I'll be measuring focusing on the smart textile right over here, and we'll be kind of talking about that. We are very thankful to our sponsors, NIH, NSF, Rhode Island Commerce. We really appreciate their support for helping us work with some of the companies in Rhode Island, and there are a bunch of other foundations that we have received grant from. But majority of our grants are coming from NSF and NIH, and also I would say Rhode Island Commerce. Um, our lab has been well connected at the University of Rhode Island. We are in Rhode Island, URI, so of course it makes sense that we can have better access to our own departments. So we work with textiles, physical therapy, kinesiology, neuroscience, and we have industrial engineering folks here. Um, of course, since we are working on health, so we have to work closely with the medical experts. So we work with Rhode Island Hospital and also associated lifespan partners. We also work with women and infants. Fab Newport is our outreach partners. We work closely with them to do a lot of outreach activities in K to 12. We work closely with Rhode Island School of Design and particularly in smart textile areas with the textile department. New England Medical Innovation Center. We have been engaging with them since it started in Rhode Island. Writing, today we are Writing is a partner with the 401 Tech Bridge, and I have been involved since the Writing was inaugurated, and have been enjoying working with some of the companies. Cooley is the textile company. We have worked with them before. Nautilus Defense, we have been engaging with them recently, and we are going to start a project with them. We are pretty excited about that. And TheraCycle is a Massachusetts-based company, more into the physical therapy. Our lab is extremely diverse, and at URI, we kind of, diversity not from just only cultural background, but also diversity in the mindset, gender, what do you call it? We have it in our lab, and we really believe that this diversity brings innovation, and it actually happens. So I'll be showing you in my slides how it works. So let's dive deeper into the today's topic, right? Smart textiles and what it means. So, first of all, you may have heard about different kind of terminology out there when you're looking at the textiles, particularly with the technology integration into that. So smart garments, smart fabrics, e-textiles, smart clothing has been used many times. And of course, then you might be even hearing based on the wearables, like smart shirt, smart socks, those kind of thing. You would be hearing that. So what is smart textiles, right? So smart textiles, I think, if you categorize smart textiles into different categories, here is something. So one is called functional fabrics, right? So functional fabrics, that means it may not have a lot of integrated electronics in that, but there are fabrics that are functional, that they are designed through particular kind of fibers, could be composites, and then they have some kind of properties that if they are heated up, then they change their properties. So those are functional fabrics. Then comes the sensing, and you could integrate sensors and electronics into the textiles, and then you can make, let's say, smart shirts, for example, and it would be doing in a electrocardiogram for somebody. So it becomes in a smart sensing shirt that it is allowing you to collect the data of health. And then there are kind of textiles which are, I would call it, an ultra smart textiles, which also have not only sensing but also has an actuation. And what actuation it means is that it can be, for example, it would be having a vibrotactile motors, for example. It would have some vibrations or buzzers inside. It could change its shape, for example. It may have a soft robotics embedded into textiles. So those kind of actuations can happen, and many times they have to be working in coupling with the sensing part of that. So this is in general. You might be aware of, if you go and Google it, if you look at some companies that are starting up right now in the smart textiles industries. And it's I would say that we are at very beginning phase of the smart textiles right now, and we will be seeing a lot more things in the future. That's what my feeling is. So in smart textiles, I have chosen 4 projects, and I'll be talking, giving you overview of these projects, and it gives you an understanding of when smart textiles are in a research phase, what happens. So none of these items, what I'm going to show you, are out there in the market, by the way. So I want to make it very clear that these are all research projects. So you might be seeing projects which would have wires coming out or those kind of things, or it may not be looking as elegant as you might see as a smart textile products out there. But any product which is out there, they have to go through this stage. So I would like to kind of show you that what happens when you are in an infancy stage. You come with a concept, and then you are taking those concepts toward the application domain, right? So let's start with the e-textile knitted sensors. And first of all, I would like to kind of acknowledge my collaborators, Anna from RISD, and this project was actually funded by Rhode Island Commerce. Nick Constant was the applicant of that particular project, and Nick Constant is a PhD student in our lab. So here we have a knitted e-textile sensors. What it means is that you can use a knitting method to design a sensor. And how it would work is that you need to use the conductive threads that so here I show you an example. So what happens is that, and by the way, this is not a hand knitted things, this is the industrially knitted sensors. And these sensors were designed by Anna, and then you can see the loops over there. That loops are actually created through the conductive thread. So one of the threads in the knitted structure is conductive, and then in the pulse in the digital world, when you're creating your knitted structure, you really define that where the conductive threads need to go through and where they will be ending up in the structure over there. So you can actually target how you want to create the sensor, and you can change the density, you can change the structure, you can also change the conductive threads, by the way, which if industrial machine is allowing you to integrate the conductive threads, by the way. And not all all knitted machines can allow the conductive thread. So you may want to look at, because sometimes the tension of the conductive threads are very important matter in the industrial machines. So here, we also have other team members who are helping testing this. Anna has created a number of these sensors in before COVID, by the way. So in 2019, late 2019, this all the sensors they have created, I would say something like 20 different types of sensors, and with a different kind of design, different kind of structures. And currently, we have the team working behind it to see that how these sensors are performing, right? And sometimes it is not necessary, it has to be only knitted conductive based sensors. Also you can have some other kind of sensors like a pressure sensor. Still you can use knitted method, but you don't you do not use conductive threads as a element for sensing, but you can use in a different way the knitting method in that case. So here I'm going to play a video so you can see that how the performance monitoring test can happen. And everything is incubated, by the way, within our lab for creating this performance testing setup. So you are seeing essentially the data coming out of that sensor, that 3D designed robotic system, motorized system that we have created. And it what happens is that the when sensor came in the beginning, we were doing with our hand, 10 cycles and all this kind of thing. But as soon as we brought in, Rumon, our textile engineer, he said that we need to do, 2,000 cycles and 10,000 cycles, and we can't do it by ourselves with the manually. So we had to start working on how we can create a motorized system that we can do this kind of testing for so many cycles. And it makes sense, right? Because these sensors are not designed for just 50 cycles. They are designed for, it has to work for at least 10,000 to maybe more than that. Uh, uh, um, and these are the data what you are seeing in the screen. The data what it means over here is that you would be able to measure the its stretch, and actually you can have that stretch measured very accurately, and you can calibrate that as well within the sensor. And that's not really easy process, because each and every sensor, and these are the needed sensors, right? And with the different structures sometimes, so you may require different calibration process, and their sensitivity can be different. So here you are seeing that when it is the resting state, right, here you are seeing the resistance. So on the y-axis I have resistance, and x-axis I have the samples. And so you can see that the resistance was higher when it was a resting state. As soon as it stretched, the resistance got lower. And we are still working out on an electrical principle behind that, because based on our hypothesis, whether it should be working in this way or not, we have some questions regarding that. So right now we are trying to figure it out from the resistance principle point of view, the electricity principle point of view. Let's go to the different project, the infant physiological monitoring. Here this project particularly, what we are interested is we are closely working with the women and infants, and we actually just received a very small project, as a small project on a concept project funds from NSF, and just to see that whether this kind of smart textiles can be used onto the infants. And Gosde and Dr. Solanki, they are currently working on this project, and they also have other team members. So idea over here is that you have sensors that we were seeing, one like a knitted sensor, for example. But in this case, we are showing you an embroidered sensor. And if embroidered sensors can be embedded into a belt, which could be a chest belt for infants, and can we do a physiological monitoring? And application point of view, this can be used for newborn babies, or even a premature babies, as well as the infants which have some health conditions, and how you can make this technology more usable, rather than they are kind of restricted to certain infrastructure. For example, it has to be happening in hospital. Can it happen at home, for example? So those kind of futuristic idea we are thinking. And so here, these sensors, and we, of course, it goes with a lot of electronics. So I haven't shown you electronics, but we also, there is a whole different core area where we work on is the electronics aspect of that, that how you can create electronics that connects with that. Here I am showing you an graph over here that shows you that the red line, it shows that this is the way the respiration was provided to the robotized baby. This is actually mannequin that came from a woman and infants hospital. And the blue line, which shows you the data that we collected from the sensor. So we were seeing that whether clinically we could use such kind of sensing technology, right? And we are getting there. This is, by the way, very raw data. We haven't applied any kind of signal processing or any artificial intelligence in a new term, I would say, in a today's world. We haven't applied anything yet, so we'll be working more in that area in a year or two. Also, if you go towards the more details, like if you look at more details, like what kind of problems maybe this kind of baby is facing. Let's say if a baby is facing an apnea episode, and what it means is that there is a stop in breathing for several seconds, and can this kind of technology detect apnea? And we are not sure yet completely that it will be able to measure that. But we are getting in that direction right now, that we want to make the system robust enough that it can detect this kind of adverse event. Let's go to the different project. I'm sorry that I'm kind of highlighting the project pretty quickly, but our time is limited. Smart textile gloves. So I'll talk a little bit about that. Let me play a video. I hope that our sound will work over here. Let me know if your sound doesn't work.
My name is Andrea Hopkins. I'm 71 years old. 15 years ago, I was diagnosed with Parkinson's disease.
Andrea uses an app on a tablet which connects to the smart glove wirelessly. After the connection is successfully established, the app guides her to perform specific movement tasks. The smart glove has several high-resolution stretch sensors which can pick up fine-grained symptoms present in the hand and fingers. The glove data is sent to the tablet for storage and analysis.
Yeah, another thing is that we also have, this kind of sensors that you were seeing, the pressure sensors. They can be embedded into shoe. Sometimes we ourselves, we are using this technology to really see the proof of concept. So now smart textile gloves has completely we have, I would say, a third version of smart gloves. And we have worked with, we have also received, help from some of the textile experts. I believe that Adrian Burke is over here, who is actually helping us in the background, that how we can make these gloves translated from engineering design to a smart textile design, or textile design, I would call it. So this is a very recent design. We have and Vignesh Ravichandran. He's our master's thesis student. He's actually defending his master thesis on this Friday, and he has deployed this particular technology in 3 patients' home. And we recently collected the data from the patient. They have used this technology in around 2 to 3 weeks. And we have received some kind of really good comments on where it worked and where it didn't work. This was our, by the way, very first experience of collecting the data from home using a smart textile technology. So we are pretty excited about that. And what it comes with is that you have a smart textile glove. Then also you have a tablet, and this tablet is not like an Android tablet or anything. This is a tablet that we have developed from the different kind of parts. And then you have a touch screen over there, and then patients would be they would have a guided data collection process over there. And what it does is that essentially it collects the data from the patients, and patients will be doing guided exercises, something like a finger tapping, open and close hands, something like that. And then we would be able to collect the data, and we could analyze this data and can help doctors to really understand that whether their medications are working on the patients or not. And we are hopeful that we would have now we are going to work on a um, on algorithms that it can detect those kind of fine motor symptoms. Here is a, by the way, people who are coming from a manufacturing world, we definitely need your help, because of course we don't want to create something like this and send it at home. But of course we have to start somewhere. So we started with the flex sensor, which are out there, commercial sensor. We would love to kind of integrate them in a better way from the manufacturing processes. And we are going to have a one textile designer, and thanks to Adrian actually, that who has helped us found a one textile designer from URI, and we will be kind of figuring it out that how we can make these gloves more user friendly. Last but not least, e-textile NFC technology. So this is the place where we work closely with Cooley groups. We were funded by Rhode Island Commerce in that, and we had early concept design on NFC technology that either we can design from the conductive threads, and we can use embroidery machine or sewing machine, and we can create the NFC technology, or we can use a flexible substrate and a chemical etching process, and we can create the NFC or RFID tags. And essentially, the idea was that how we can increase the range of the NFC. If you are using an NFC technology today for payment and everything like that, the original idea is that can we increase the range? We don't want to increase the range that it needs to be something like a 10 meter or so, which is impossible to do it with NFC. But we were trying to see that whether we can increase the range for few centimeter. And actually, Inayat, sorry, I forgot his name to write over there, but Inayat Rahman, he did his master thesis on this. And um, so what we actually found out that we were able to detect with the new kind of NFC technology, we are able to do 8 centimeter detection range. So if you put your phone close by to the detector for 8 centimeter in the range, you could detect that. And it could have a lot of different applications. By the way, and probably if you look at Cooley is a more consumer product kind of facing technology. So you can think about from the consumer standpoint, and there are a lot of benefits of such kind of range if you can bring it in. Of course, this wasn't a healthcare. We definitely can find some healthcare applications of this NFC technology as well, and we're gonna be kind of going back and rethink about that. uh, um, I think. Oh, and last but not least, we have received thanks to our College of Engineering, who has offered us and very generous support. We have received a JSK embroidery machine, and this is not a conventional embroidery machine. This is a designed for smart textiles, and so essentially you can use a conductive threads, you can have a wires, and you can use the different kind of heads over there, and you can create a different kind of you can do the different kind of embroidery method on this machine, and you can create your own uh, circuits over there. So I'm showing you in the right side some examples. For example, you can embed the textile circuits on that, so you can create electronic circuit. It could have, here it is actually showing you an example of touch pads, and you can create a touch pads, and touch pads are connected to the circuit there. You can create a different kind of stitch method, something like a chenille stitch or Mohs stitch, and you can use the conductive threads for sensing. You can also use the embroidery machine to create a pressure sensor, so some other kind of sensing methods out of that. So we have been enjoying JSK machine for I would say around a year. We got a good hand on that now, and Gozde, our student, Vignesh, Nick, we have and Rumon. We all are kind of currently working out, how we can maximize the use of the JSK machine. So if anybody here is interested in the use of the JSK machine, you can touch base with us, and definitely URI is pretty open in terms of the innovation and research. So we would be happy to kind of work with you. Uh, Beside that, of course, it's not only about research. We do bring this kind of technological development in our courses. So we have courses. Currently, I'm teaching BME capstone, but in the past, I was teaching about wearables and engineering entrepreneurship. So we used to bring this kind of concepts, and we were teaching kids, in the college, by the way, that how you can kind of come with a concept and you can bring a prototype out of that. So that is cool. We do hackathons at URI. Hopefully, we will be able to do hackathon sooner in fall if COVID restrictions would be lifted. Um, we also have innovated at URI. It's a launch lab. We do a lot of innovation in that, and I was a part of the AI lab in library. So it helps students to gain access to the state-of-the-art computing infrastructure, and you can create codes, you can create robots, you can create anything which connects with the data and the real systems. And with that, I would like to thank everyone for being here and listening to my talk.
Thank you very much. I think that we do have a couple of questions in the chat. So Miguel, do you want to launch questions?
Yes, of course. We have a question here from Nicole. She says, fascinating projects, specifically related to the knitting e-textiles. Are these adaptable to larger and smaller sizes? Could these be applied to a flexible orthopedics/sports brace, such as a flexible knee brace?
Nicole, thank you for the question. That's to answer this question, it's a little complicated process. I would say that whether you can scale this for a bigger, but I really like the application you mentioned about the knee brace or a knee rehab, whatever we call it, or required. We can definitely create something like that. It does require a lot of two kind of testing. First of all, let's say from the knitted technology standpoint, we do need to work with expert like Anna, and then we need to figure out that okay, let's scale it. Right now we have sensors which are, I would say, biggest size. I would say it is a 3 each by 3 each. For example, we had that kind of size. We can scale it, but does scale help? So that is something we need to do a testing of that. So then we do a testing through those kind of benchtop testing to start with, and then of course afterwards we have to convert that benchtop testing into a human testing, and we can do that as well. So but yeah, this is I think definitely an area we are very interested in, that whether we can scale it. And there are different kind of scaling, by the way. Scaling in a size we can have it, and another scaling is a scaling in the layer, right? So it's not just one layer, but maybe you can have multiple layer of needed thing, and can we do something like that? So that's definitely a fascinating area to go towards. Thank you.
Thank you so much, Kunal. We have another question from Sol Brown. What has been the reception by the healthcare industry to these concepts? Resistance or acceptance? What issues do they present? Smart textiles.
Yep. Sol, good to see you after a long time. Reception, I would say we are gaining an acceptance over time. It's a different world over there. They do not understand smart textile, what it is. But I think the people like us, we have to go and advocate for the smart textiles. And something like this, what we are doing today, that kind of thing needs to happen more in the healthcare sector, to really see the smart textiles and in application going out there. We need to convince doctors. We do need to convince policymakers in the healthcare side of that how we can make this happen. One thing I definitely want to mention the name is the IPC. Actually, it's an standards organization, and they are making they are definitely putting a lot of important efforts in the area of the translation part of that. So standards, and then I don't see healthcare over there, but we love to see IPC and maybe, that kind of standards organization working closely with healthcare.
Thank you so much. Another question from Paul Hruska. Have you conducted any studies to see if the performance of these sensors is affected by laundering?
Perfect question, Paul. We would like to start that research. We come from the biomedical engineering and electrical engineering. So now we are trying to figure out how we can bring this laundering based kind of research that I know, because it's cycling, washing, all these kind of things is going to affect the performance, and there is no doubt about it. We know that that's going to be either limited. So how we going to do it? That is the kind of conversation we are having internally in our lab. We are also looking for partners in that particular area. That if anybody is interested in if they have facilities that they would like to collaborate with us in that aspect. So we don't need to kind of buy washing machines over here.
Right. Thank you so much, Kunal.
We are right about at the time we'd said. So are there any other questions before we wrap up? Add them into the chat. But Kunal, I do want to just say thank you very much. It was fascinating. I'm curious if you could just close with just a second of what do you think the future looks like for this? When do you have a sense of when we might see more adoption of the e-textiles and smart textiles in products that we're using every day or in our clothing? Are we looking a decade from now or 5 years from now or further out?
Mary, thank you. I think looking at the future, I think future is right now here. There are a number of companies who are designing smart textile based products. They may not be visible sometimes. There are particularly in the sports arena, there are smart textiles products out there. For example, smart underwears is not a new concept anymore. They are being used for maybe training of different kind of players, right? There are may not be in healthcare we directly see, because there will be FDA coming behind us, and this is needed, right? You need to have a regulatory behind you for that. But in a sports and wellness sector, there is a lot of things coming out already. So I think it is a good news for that. One area I would say that we still need to work more in the smart textile area. The smart textile industry is the building the infrastructure for manufacturing of smart textiles, because there are not that many players out there who can do the smart textile design. I would say that not only US, but I feel that the countries where the infrastructure is already there. For example, in Asia, there is a really good infrastructure of textile manufacturing. So if globally there are more collaborations and partnership can happen, that okay, here are the demands and here are the manufacturing processes happening, and how you can create that kind of infrastructure. I think that is something need to happen in next 10 years, that we need to be talking more globally about that how infrastructures can be leveraged for having this manufacturing happening. And another area where we definitely should be mindful of is a sustainability of the smart textiles. And I feel that maybe Rhode Island can do something about it. I feel we have a textile companies over here, and if we are, let's say we are thinking about the smart textiles, can we bring that kind of designs that they can be sustainable? And it can be uniqueness, by the way, from if we look at from that aspect of that in the Rhode Island, that if we can bring as a sustainability as in a core area in a smart textile development, we could be really unique, and we could see more people coming to us in Rhode Island, because we have some basic infrastructure and we can have some investment, and we can go more towards sustainability aspect of that. I'm sure writing is definitely working in that area, so we can think more about that.
Excellent. That's fascinating. Thank you. So again, thank you so much for presenting today. I'll mention for everyone else that our next talk is on August 10th. And we'll feature Professor Aaron Bradshaw, who's an associate professor at URI who focuses on offshore wind energy. And he will be joined by Zach Miller of Triton. He has an industrial project going that is related to the offshore wind industry. So again, that's on August 10th, and we hope that you will join us again and also share this with your colleagues. So unless there are any other questions, I think that we're pretty much at time now. Thank you all so much for coming.